Okay, good morning. Today we're talking about systems of equations. Everybody should have their Nearpod activities uploaded and ready to go. Everybody's logged in. So, everybody's groups, you're there. I see my group A, B, and C, and I see the names. Anybody need any extra time to get that situated? Yeah. All right, take a moment. The login code is OSTGQ. OSTGQ. Okay. Thank you, sir. So past, present, future, we talked about all the types of systems. Today we're going to do real-world applications with them, and then we're going to determine which method is the best. So what's really important about today is we're going to learn how to take a word problem, we're going to learn how to analyze it, we're going to break down the parts of it, and then we're really going to dissect what's going on, and then you're going to create your own. Okay? So here's our first situation. You have a handout in front of you. I want you to take a moment and read that. And then we're going to break it down in terms of parts of the equation. Okay, so we should be looking for two equations whenever we're trying to create a system. Venetia. The quantity equation. I need something that represents a total of how many of the unknowns that we have. Give me an equation. X plus y equals 100. That represents the total amount of unknown test tubes. You can write that down on that paper as we go along. Now, here's the other equation. Since we talked about how many we have, they told us some information about how much each one of those costs. Terrence, can you tell me a term that represents Acme test tubes if they cost $10 each?
X would be
Acme, yeah, X is Acme.
And a term that represents center test would be Y.
Hold on. $10 for every one of the Acme tubes.
Yeah.
So what can we say? $10 times X. 10X.
Yes.
Okay. Alan, give me a situation that represents Zenith test tubes. They're $25 each.
25Y.
25Y. So I can say 10X to say $10 for every Acme tube, and I can say 25Y to represent everything for Zen. Now the third part says use the terms you found in exercise A and B, and I want you to write an equation from it. Gauge. If I were to put those two together, give me an equation for part C.
Wait, you just said X is 25. 10X is 25Y equals 2,000.
Right, so he's putting both of the amounts of each one of those test tubes together, and they told us the total price. It said it was $2,050. Okay, so that's the total cost equation. We can take both of those equations and we can put them together. I want you to write, and then we're going to solve it together, but I want you to write both of those together. Create the system. That's what's happening here. And I'm going to demonstrate how to solve this using elimination, because that's what we've done before. The elimination method, we say that's whenever we try to multiply to get something to cancel out. If I were to eliminate the x values, because we can do either one, what can I multiply x by to make them cancel out? Anybody? Negative 10. Thank you. Okay, so what's my new type equation? Negative. Okay. Let's just bring our top equation down. So we're trying to eliminate the x's. Do they eliminate that? Yes, they do, because they add up to 0. What's that going to be?
15,
1,050. Positive, right?
Yes.
And then you divide, and y is going to give you
7.
7. So if we have 7 and we plug the 7 back in, which equation would be better to use? 7. First one, does it matter which one?
No.
No. I would use this x plus y equals 100. That's just me, because the x's and y's are by themselves. So x plus 7 equals 100. Subtract 7.
X is 93.
Okay. So my coordinate would be 93, 7. So x represented what? Jamisha? Right. The active test tubes. We must be buying 93 test tubes. And then 7 represents zenith. So 93 of those and 7 of those. Yes, ma'am.
Why should be 70?
Yeah.
70?
Yeah, we made
Oh.
a minor mistake.
Sorry. Thought I heard 7. So in that case, this would be what?
That would be
93 times 70.
that would be 30.
30 makes more sense.
Yeah,
We're going to talk about
yeah.
making sense later. We're going to talk about making sense a lot later.
Yeah, now it makes sense.
It makes sense. It balances out. There. Thought I heard 7. That's okay. I got those over me. So this is elimination. We can solve this using substitution. For substitution, I'm going to take the same equation. 2050. All right. When we solve something using substitution, we have to rewrite one of the equations. Which one would be better to rewrite?
X.
Top.
Yeah.
Top. Chelsea. Rewrite that. What do you want to solve for? Solve for x. So what do you do? Move the y. So I should write what? Okay, I rewrote the top equation. So if I'm substituting, last week we learned that we can take that and substitute it for x. So it's going to go right here. So it's going to be, well, I'll bring this down just for sake of saying that I'm changing that first step. That's just what I do. I just like to do that. So I'm going to take all this and plug it in right here for x. So 10 times negative y plus 100 is 25y equals 2050. This is an equation. We just need to solve the equation. What do I need to do first? Distribute. Negative 10y plus 1,000. Okay. What do I do next?
Add like
They're on the same side, so we can just combine them to get what? 15y. Subtract 1,000. 15y equals 1,050. This time I know that the answer is going to be 70, not 7. Not 7. So I'm going to plug the 70 back in, and look, we're going to have the same answer as before. Same answer as before. I did like 37 last time. I did. Just checking. So it doesn't matter which method we use. Elimination or substitution is really just a preference of which one you prefer over the other one. Okay. So the question is, which one do you prefer? Elimination? Well, that was kind of verbal. I was going to ask you on here, in your group or however, answer the question. Let's see how the class feels about the methods. Which one do you love? Answers populated. Looks like most people love the elimination method. A couple of answers. 5 more person. All right, okay, elimination. I like elimination too. Just double checking. All right, so here we go. I've done one. Now it's time for us to try one. There was a lot of talking, a lot of out loud. Let's really see what you can do. So we're going to do a little think, pair, share. I want you to think about these questions that we're about to do, and then I want you to work with your group to come up with the answers to those. Starting with this. I will give you 2 minutes. 2 minutes to come up with answers to those questions. Have any questions for me, let me know. Yes, sir. When you start with reading it, first thing is to think about what are the pieces, like what are the unknown values. Like you have to think about all of the parts of the word problem. I have to figure out what's unknown, or at least understand the situation. So that's what I would do for the first time.
So you said yeah, so that'd be X mark. So something right. That's what we're saying.
Of the variables in the equation. So you have to deal with it.
We read the question and what does X and Y mean? We read.
Yeah.
Number 30. You have to have Oh, no, I'm talking about number 3. So for 2 variables, you have two different equations.
Keywords, so they're telling you what to multiply by. So, example for x, and they're saying 10 each, that's 10x, 25y. So that's how you know if it's going to be coefficient, because they're
Sir. How would you find number 2? So like how would you classify the coefficient?
Remember the second equation? They were saying $10 for each athlete, and then it was like 25 for each. So what does each tell us about coefficient?
How many are there? How much would it cost? Or how much would it be like whatever
For each one?
Yeah, for each one.
So therefore, they're telling you that you're multiplying. So that's how you know it's going to be a coefficient. So that's something you can kind of put in words.
So it's telling y'all that what the variable is being multiplied.
Okay, folks, we got to get through this activity. So now is the pair part. So even though you're not all the way through number 4, most of you there, it's time to pair together and let's discuss some of those questions or some of the answers that you have with your groups. Do that now. Turn the music down.
We know
Well, as a group, let's talk about it. They said, we'll solve the systems of equations by substitution or elimination to give you the same answer. What you see? Why does it?
just solving on there to your X on Y.
It's different, two different systems of calculating out the
Two And he just proved up there that it's 2 ways of solving.
Okay, give it another 30 seconds. And then we get to display our answers. Quick readiness check. Thumbs up if you're ready. Okay, you ready? Good. This is what I want you to do. In the first question, I want everybody to respond to this from your groups. What is the first step you should take when setting up a system of linear equations? Let's see where the disparities are. Let's see all the different types of answers. Like, what do you think needs to happen first when we have a word problem? Okay. Somebody says find x and y. Somebody says find the equation. It's kind of hand in hand. Find the factors that are unknown. That's almost like x and y. Yeah, we got to find the unknown things in the equation. Drag this down. So find the unknown values and plug them in the equation. Still, I'm saying something that's common. We need to find unknown things. What is unknown for the problem? Find x and y, find unknown. Okay, so what can you say based on seeing all those things? Find the unknowns. So when you look at a word problem, you gotta say, okay, what's missing? That's what you need to think about. Here's the next thing. How can you find the coefficients of the variables in the equations you use based on a real world example? So, what would be the coefficients? How would you know? Okay. I love group A. The keywords. We look for keywords. Somebody said, I'm sorry, whoever this person is, they'll leave that later. Whenever I get on. Find out what you're multiplying by. That's another thing. So coefficients mean you're multiplying. So if they're saying that something's per whatever each, somebody says it's what the variable is being multiplied by. So you'll see something in the problem. Reread the equation or the problem. Use what you do know and plug it in with x and y. Okay. The main thing is a lot of you are saying, when you read it, yeah, you gotta read it. When you read it, this is what you're looking for. The key words. I saw somebody say that. What would have been the key word for when they said $10 for every Acme, $10 for each? Each. $10 for every or for each. So they're saying that you multiply 10 times the unknown value, so 10 each. Okay? Two more of these. To solve for two variables, how many equations do you need in your system of equations? How many do you need? We're going to find our answer. How many equations do you need? Exclamation marks. Not two. You're quiet, but there's still that enthusiasm. Two. All right. You need two. A system is two equations. Later you'll find out that it's two or more equations. Or two variables or more variables. Okay. will solving the systems give you the same solution? Were my answers the same? I said explain. So is my answer the same? Why would they be the same? Okay. Yeah, they're supposed to be the same. It says they will give you the same solution. The equations are never going to change, so therefore the answer is supposed to be the same. Yes, because you are just doing you're doing different operations, but still you're going to get the same answer. I just needed you to know that. That's kind of checking on that. Let's see. Let's check our time. This is our first thing. I just want you to do a little mini activity. You'll notice in your groups there is a little plastic baggie, and there's some equations in there. This is for situation 2. We're going to do some shuffle cards. See my little picture? Shuffle cards. Let's learn how to represent equations, because that's my focus for this activity here. I want you to shuffle the cards and place them face down as a group. I want you to read the following problem in scenario 2. It's on the handout. And figure out which equations is going to match the situation. Go. You got a minute. Let's see who gets there the fastest. Raise your hand when you get it. Which equations go? 2 equations. Let's see who can get there. Energy.
We got it.
Oh, we got it.
Whoa.
Yeah, we got it.
Sharp. First place. Second place. Let's see who's right. I'll give you a second to finish.
It's alright.
Give you a second to finish.
I like the 2 equations that was matches. Okay.
Group D is going to give us the equations whenever we finish. Got it? Okay. We're going to check what group D has. Got it? Thumbs up if you're ready. Almost. We know group B. Got it? Group D. What would be the first equation? The quantity equation.
X plus Y equals 233.
Right? And give me the next one.
14x plus 20y equals 3,748.
So as a group, I guess I was calling a group. Yeah. All right. Okay. All right. Now here's the thing: the constraints. Like whenever we find our answer, it's supposed to check out. Like if we get x and y, if we were to plug x and y in, they're supposed to add up to 233. If we were to plug in x and y, they're supposed to multiply to 3748. So that's like our reasonable constraints of our problem. If it doesn't work, like if I just try to make up something and it doesn't work, then I have to adjust the equation. But we were given the situation. This is what I want us to do now. This is kind of a, I did it, you did it. Well, I want you to do it again. What do you think DIY stands for? Do it yourself. You do it. It's all on you. This is what I want you to do. I got different groups, different levels. Group A. Group A. I want you to draw, with that paper, I'll come around and get it. I want you to draw a system of equations, label your axis, and then interpret your answer. Group B and D. I want you to just come up with a system, like create a situation where you're trying to figure out when we're going to come up with an intersection of things. kind of like you did before. And then I want you to interpret what does your X and Y mean? Like, what are the variables? So you have to have some variables in the problem. And then where's my group C and E? It's my outgoing groups. I need you to create a system of equations. And then I want you to try to create a skit that goes along with it. All right. You got 7 minutes. Let's do it. Talk to me if you have any questions. Yeah, you're just for drawing. Ms. Underwood, are we going to have to converse with them? You don't. 2 different groups. There you go. The marker's over there on that table. Send somebody with markers.
But there's a 5-star.
Yeah, it's outside.
No, that's yeah, don't. Yeah, come on, come on. You only got 7
Okay, X will be what it sounds like. 5-star. 5-star.
How much is
But it should be expensive.
Remember how much money we got to buy?
So like $25.
What's the total? Yeah, what's the total of all what we trying to
We got 100.
Wait, what's the total?
Okay.
Alright. So right now, it's first. How much we gonna buy? So that means
Are we able to make it any bulk?
Y equals $0.
We go to the store, buy how many and feed and we reuse it, so
Yes, you can close it.
Like $1.
So it would be cheaper start with the first one, plus like 25. And they only have like how much money they have to spend?
$100. $150.
X. So you going like how much you sum amount? So so it would be like 2X plus 150.
So let's do
But if it was to be the same amount, we may need both equations. We have to put something else. So how many orders that we
Work it out.
we could put X plus 1500 Because if we do
Well, y'all working out.
yes, create so many ways to help
Okay, just make it
Somebody have any questions for me as they're working, or?
We need to create a song as well.
Yes, what kind of songs?
So Y was 200.
Right on next to it.
Yeah. And then second.
How much okay, so in this case, we wouldn't be thinking X plus Y equals 2. We would have to get 2 plus 3Y equals 2. You say
I thought it was like 100. No, like
I guess you don't
35.
we need to change the problem a little bit. He provides
Are trying to fix the problem.
Because of time, I really want to finish this activity. So we're just going to have to continue it tomorrow. I feel like everybody's going in the right direction. Make sure your group letter is at the bottom of your activity. And I'll close out with this. Thank you. So that's all, folks. I was working on this with my daughter. She says, well, it's not right if Pinkie Pie's not in there.
Oh my God, my sister would say the same thing.
Yeah. So we learned with the think there shared we need to look for certain variables. Hold on. Make sure you write your group name on there. And we know that we need 2 equations, and we know that there's more than one method. So that's really the major part of this. So tomorrow we'll continue to define these situations with our own do-it-yourself project. Homework tonight, please. If you get it, I want you to do textbook page 359, 1, 2, and 5. If you don't, I want you to watch a video, and I want you to take some notes on it and come back to show me that you tried it a different way. Either way, try either one of those activities. Okay? Thank you. You're free to go.